Good evening, everyone. I'm Chimela Ariasaf, and today we are talking about the week 6 assignment about the open source tools for efficient model development and deploying our model, the predictive text analysis, analytics, and sentiment analysis on customer feedback. Next slide. These are the group members: Abonga Ronald, Chimela Ariasaf, and Moses Edwin. Next slide, we are group E. Then the MLOps tools overview that we used in our project. We used the MLflow for experimenting, model versioning, and deployment. Then we used the DVC for data and model versioning alongside code. Then the Prometheus and Grafana for monitoring the model performance and visualizing. Next slide. Next. I'll talk about the hands-on tasks. First of all, I'll begin with experiment tracking and model versioning with MLflow. We started by installing MLflow, and we installed it via command line with the command pip install MLflow. And after installing it, we are able to go to our project directory. Then we ran the command MLflow UI, where it ran and it executed and gave us a URL. Then we copied that URL into our browser, and then it ran. After running, it was able to show us what our project looked like. And then after that, we did the model deploying, where we used the Pico as a container for our file. Then we containerized it there. Then we had to run the model, and when it ran, it deployed on a local server. We didn't deploy it on a cloud server. Then from there, we had to bring in DVC for data and model versioning. And how this worked, we began by installing the DVC still via the command line with the command pip install DVC, and it installed. Then we had to initialize it in our project using that DVC init to initialize it. And then after initializing it, we are able to import all the libraries of DVC into our project. Then we are able to use it. Then we had to add our data set to the DVC using the command DVC add, then the data set name. Then we added it. The importance of adding it is to track changes to our model, to track changes and model versioning to our data set. Whenever changes have been to our project, can be reflected on a GitHub. And after that, whenever changes could be committed or push, you can push changes, you can pull and push changes, and after you can merge them on GitHub. Then from there, we went for model monitoring with Prometheus and Grafana. As it is, we began by installing Prometheus and Grafana, downloaded. Then under Prometheus, we had to first configure the Prometheus.yml file by adding the job name as our model name. Then the target URL was the deployed URL. We had to use that URL, but remember our project, we had deployed it on a local server, so we had to copy that URL, then we had to paste it there, and we saved the file. Then after saving the file, we had to execute the Prometheus stuff. Then after executing it in the terminal, still it gave us a URL. Then we ran that URL in our browser. After running it, it displayed stuff about our model. Then from there, we had to run also the Grafana. We had to run it, and after running it, it gave us the URL, and we also copied it and pasted it in our browser. Then after pasting it there, it displayed the web view. Then after displaying, we had to log in using the admin credentials, admin for username, admin for password. Then from there, we navigated the dashboard. We had to create a new dashboard. Then creating it, you navigate to the tools there. We have Graphite, we have other tool, then Prometheus. Since we are using Prometheus, then we had to choose that one. Choosing that one, then you set up. When you choose your setup, the URL of that Prometheus you're going to use to monitor, you paste it there. Then after you save, then after saving, the results were displayed, the model, the CPU usage resources, the resource tools, the memory, the CPU, all those were displayed on a page. And that's it for me. I'll leave the next colleague to continue. Thank you.
Hello, my name is Edwin, and I'll be taking us through the challenges that we faced um, during these MLOps operations, machine learning operations. Yes, one, we have the integration complexity. Integrating multiple machine learning operations into an existing workflow would be complex and time consuming. We found it time consuming that we found ourselves having to even ask for more an extension of the deadline for delivery of this assignment because we kept finding because we're using these tools for the first time, found ourselves uh, having to spend a lot of time understanding, reading through the documentations of these tools to understand them and be able to deliver. So the solution to this could be a breakdown of the integration process into smaller steps, then reviewing the documentation of each tool, and this can help you understand or explain what that tool can do and how you can utilize its abilities to deliver exactly what you want from your MLOps. Then there's tool compatibility. It could be challenging to ensure the compatibility between the different machine learning operation tools. And this you could resolve by conducting a thorough compatibility check before integrating these tools to know do the things actually work together or can they deliver together. And also there's a consideration of using middleware or adapters to bridge any compatibility gaps between these tools. Then there's training data management, the management of your training data. So if you're having large volumes of training data, and it becomes challenging ensuring the versioning and the productability. And the solution to this would be to use to utilize the DVC that Ariasaf was speaking about to version control datasets alongside the code and establish clear data versioning and management practices to ensure this productivity. Then there's monitoring the setup. So setting up monitoring systems for both the model performance system metrics can also require significant configuration and the fine tuning. And should be to invest time in understanding the monitoring tools configurations to be able to could you give me the next slide? Ronald, could you give me the next slide? Yes, you invest time in understanding the monitoring tools configuration and the best practices. And then there you can be able to apply and fine
Edwin, are you still there?
Oh, sorry, my network kept going on and off. So yes, but in brief, that was the challenges and the solutions we had. Yes.
Okay, thank you. I'll be taking the team. I'll be taking.
Ronald, you could take us through.
Yeah, so I'll take you through the impacts of MLOps practices. Here we've listed 4. I'll start with model deployment. I'll start with model deployment, and then I'll touch on each of the tools that we've used. Not all of them, but at least I'll try to highlight how these have impacted in these areas that we've chosen. Model deployment efficiency. ML flows tracking component helps streamline model deployment by providing a centralized platform to log and organize experiments, parameters, and metrics. With ML flow, people engaged in these activities, those in AI, machine learning, data science, can easily track and compare different models and experiments, accelerating the iterative development process. Then DVC ensures efficiency in model development by versioning datasets and model files. This allows the practitioners in this field to efficiently manage changes to data and code, collaborate with team members, and reproduce experiments seamlessly, reducing the time spent on troubleshooting and debugging. We shall look at the other component, reproducibility. MFlows tracking and projects components facilitate reproducibility by capturing experiment metadata, code versions, and dependencies. This ensures that the experiments are reproducible across different environments and can be easily shared and replicated by other team members. When you're trying to check out results, you are able to reproduce whatever you did on the other platform. You want to see whether on a different platform, if you do exactly what you did the other side, are you able to get the same results as you got the other side? That is reproducibility. Then DVC ensures reproducibility by versioning datasets and model files, allowing members participating in this data analysis to track changes and revert to previous versions if needed. By maintaining a history of changes, DVC enables the practitioners to reproduce experiments with confidence, ensuring consistent results. Then Prometheus and Grafana. Prometheus collects and stores time series data, enabling machine learning practitioners, data scientists, AI to track changes in model performance and system behavior over time. Grafana produces visualization and alerting capabilities for monitoring and analyzing metrics, ensuring that deviations from expected behavior are detected and addressed promptly, contributing to reproducibility in deployment. And then scalability and flexibility. MFlows projects component provides a standard format for packaging and running machine learning code, making it easy to scale experiments across different environments. MLflow supports model deployments to various production environments, enabling scalable and flexible deployment of deployment of models that people have built depending on the topic or subject they are trying to model. Then DVC supports large-scale data versioning and management, allowing data scientists and those in machine learning to work with large data sets efficiently. By supporting remote storage backends, DVC enables flexible storage options and seamless collaboration among distributed teams, enhancing scalability and flexibility in data management. Then deployment reliability. mFlow's models component provides model versioning and deployment capabilities, ensuring reliable deployment of models to production environments. mFlow supports various deployment options, including batch and real-time inference, and provides tools for monitoring model performance and drift over time, enhancing deployment reliability. DVC ensures that deployed models are reproducible by version controlling model files and dependencies. By tracking changes to models and their artifacts, DVC enables reliable deployment of models with confidence that deployed models match the expected behavior, contributing to deployment reliability. Then Prometheus monitors deployed models and infrastructure metrics, ensuring that deployed models are performing as expected. Grafana provides visualization and alerting capabilities for monitoring and analyzing model performance and system health, enabling proactive detection and resolution of issues in production deployments, enhancing deployment reliability. Yeah, so this is basically it. This is what our group had to present for you. And I'd like to thank you for your audience.